The first law of motion talks about an object being at rest will continue to be at rest. An object in motion will continue to move with the same velocity until an external unbalanced force acts on it. Right? Now let's verify this experimentally. The first experiment is stack of weight on a wheel. So please have a look at this. So what did we see? We had a car and we have a weight A. So this is our weight A. So the FPD of the car would look like this. At the time of the pull, we will have a gravitational force. Acting against it is your normal force. And to the right, we have a huge force that pulls the car. And there is a small frictional force. So that is your FBD for the car. While for the weight A, this weight, there is of course gravitational pull, normal force, and a small frictional force which would be acting a bit to the right at the time of the pull, but let's not stick to that. So now, when this entire system moves forward, will there be a normal force? No, right? Because this entire thing moved, but there is nothing pulling it forward. There is a small frictional force, but it's too small. And so this will go a bit forward, but after that what happens? When the normal force disappears, obviously, it will fall. So this is nothing but an example of inertia of rest. Right? So this is an experiment to verify your inertia of rest. Next one. Again with the stack of weight on a wheel which is moving. So please have a look at this. So here again we are looking at the FPD of the car and the weight A. Weight A is over here. This is our weight A. So FPD of the car would look like this. We have a, sorry, not a pull. At the time of the collision, what happens? There's a push. It was already moving. There was a push, is it not? Along with that, there's some frictional force. It's a small force, but I will mention it. And of course, we have our gravitational pull and normal force. So because of the push, the system stops, while the weight, which again just had a small frictional force to the right, because of which it was able to move with the entire car. The gravitational pull and the normal is there. But when the below part it stops, what happens? It continues to move. And in time, there won't be any normal force. So what happens? It falls. Is it not? But in this case, because of the magnet, it stays over there. It gets pulled back and it stays over there. If not, it would have fallen. So what we saw here was inertia of motion. Right? One last thing. The system wherein you have this thread pulling this weight up. So there's only one force, that is against the gravity you have a pull, and that's it. So when we pull this particular car, all of a sudden, let's see what happens. For a fraction of a second, it stays over there. Why? because there's nothing to pull it to the right, is it not? But once the system comes at a particular angle, what happens? The structure, red structure, it gets a pull to the right. Because of this, it moves forward, right? So that is what we saw over here. And what we observed over here was inertia of rest again. So to conclude, whatever the object or the body is doing, that is what it wants to do. Inertia of rest and inertia of motion are your two parts. So in rest, if an object is at rest, it continues to be at rest. If an object is in motion, it continues to move with the same velocity until an external unbalanced force acts on it. So this is your experimental verification of inertia, right? So now pause, have a look at the experiment. Whatever comes to your mind, whatever you feel will help you in the future to understand and recall this concept, please write it down.